bring up some audio. Good evening, everyone. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre Warren South. And seeing if I've got enough audio there. Looks a bit light on. Let me just check that for a minute. The stream audio might be a bit down. 1, 2, 3, 4. 1, 2, 3, 4. That's a bit better. All right. Okay. Yes. Welcome everybody to the ASV broadcast. I can hear echo. I'll just turn that off because I think that contributes to that echo. This is Clint Jeffrey, VK3CSJ, and a very pleasant good evening to the broadcast here on the 22nd of October, and we're broadcasting on prime frequency of 3541 kilohertz in the 80 meter amateur radio band, and simulcasting on 160 meters on 1865 kilohertz. Good evening to stations listening on 160. And both transmissions run 100 watts, and 80 meters we use an inverted V, and on 160 we use a vertical monopole down the backyard. It's a Hushcraft MA V160 or MA160V vertical near the creek. So I can see the camera is focused on the gear behind me rather than me. Anyway, that's another story. We have a problem with the ATV repeater tonight. The Melbourne digital TV repeater is currently down on the transmit side of it, but the uplink receivers are working, and hence I'm being received by the repeater and rebroadcasted by the British Amateur Television Club video stream, so you can actually see the video out on the stream. On the streamer, what they refer to as the video or just the streamer site. So go to the BATC site. I think Richard VK3VRS has supplied a link in the Discord chat room. Monitoring 23, by the way. And we also have an email address, which anybody receiving this across the world is more than welcome to send a report in the next hour. To vk3ekh@gmail.com, vk3ekh@gmail.com, and we're monitoring the inbox as we speak, and we also have a chat window running too, we're using the Discord platform, and that chat window, can be found on the ASV website at www.asv.org.au, and look under the radio astronomy tab for the ASV broadcast link, and all will be revealed. Okay, I think it'll be a relatively short broadcast tonight, but I think I say that every Friday night, and it always goes beyond 11 o'clock. But we have the usual podcast recording from the Astrophys website, and tonight's interview with Brendan is episode 10 with Dr. Elizabeth Tasker, who debunks the habitability claims for Proxima Centauri B. She debunks the habitability claim for Proxima Centauri B and explains exactly what little we know about this nearby exoplanet. So I'm not too certain how long that interview goes for. It's probably 15 odd minutes. But that's all queued up, ready to go, and probably best to try and listen to that via the YouTube stream. Not running any audio stream tonight, as usual, until I get that sorted out. But the YouTube stream is running, and so if 80 meters and 160 is beyond listenable due to the amount of lightning static, we've got a storm that's heading towards us as we speak. The Melbourne radar is indicating quite a lot of lightning activity over the Port Phillip Bay, so it's all heading towards us, and so the band is going to be a bit noisy. So you're more than welcome to go to the YouTube channel, and of course the YouTube channel can be found on the ASV website, as mentioned before, at www.asv.org.au under the Radio Astronomy tab from the top of the screen, and click on the Radio Astronomy tab, and that opens up a little down box which has the link to the ASV broadcast within it, and all will be revealed as I continuously say. Anyway, alright, I might just, before we go into, as usual, I give a little bit of blurb about the ASV, so I'll just quickly run through, for those who don't know about the ASV, as I usually do. I kick off with that little story. Alright, you're tuned to ASV Radio, VK3EKH. The Astronomical Society of Victoria was founded in 1922. It has well over 1,600 members. Membership of the Society is open to all persons with an interest in astronomy, and the Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members, which it is doing proactively. Meetings are usually held on the second Wednesday of each month. Meetings start at 8 p.m. sharp at the Mullior Hall, Burwood Avenue, National Herbarium in Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Plenty of parking is available when we get back to that hall. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library, which is located at Melbourne Observatory, receipt of the ASV's newsletter Crux. I don't have a copy with me right here. There's also the provision of the Astronomical Yearbook, a regular yearly publication. The yearbook provides data for local observations, informative summaries of various celestial objects, and other general astronomical information is available is available to telescopes. And I've missed a sentence here. Access is available to telescopes, that was it, and on members' nights held regularly at the Melbourne Observatory. These instruments include the Society's 300mm equatorial reflector. There's also a 300mm portable reflector, and a 200mm refractor, which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory, and these telescopes are accessible to members of the ASV under supervision and by the various section directors that take care of that. Regular Society Club Night meetings are held on the first and last Fridays of each month at the Society's property located in Burwood, affectionately known as the Lodge, where we haven't been for 18 months. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a wonderful 508mm equatorial reflector, beautiful telescope, and a bunch of other telescopes that folks can use to look through. Members are also encouraged to make and use the Society's country property located near Heathcote in central Victoria, some 90 minutes drive north of Melbourne. We call it the Leon Mao Dark Sky Site, LMDSS, and the site is a dark sky site. It offers superb views of light of the sky away from the light pollution of major cities like Melbourne, and is an ideal spot for visual observing and astrophotography. Members are encouraged to make and use telescopes, of course. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. And I'll just quickly run through the various 20 sections that make up those interest groups. So if you are interested in any of these activities that the ASV is involved in, the various section groups, you're more than welcome to contact the various section directors that take care of these various groups. We have the astrophotography section, probably the biggest section out of the whole lot. Very active group. Bendigo section, g'day to Graham if you're listening. The club section, comet section, computing section, Craig. Cosmology and astrophysics, deep sky, demonstrator section, diurnals. Diurnals is a section that runs during the day. It generally meets every month on a Tuesday morning, about 10 o'clock I think they kick off. The diurnals is looking for a new section director. Pat is who has been the section director for I think 16 years or more, has decided to move on, and so the diurnals is looking for a new section director. So that could be interesting to anybody that's got an interest there. Like I say, if you might be interested, just click on the sections tab on the ASV website and look under diurnals for that. Great Melbourne Telescope section, very active. We're trying to get that big telescope back to Melbourne. Probably another 2 or 3 years before we see that return to into its original place. Great Melbourne Telescope. The historical section, there's the instrument making group, juniors, lunar and planetary, meteor section, new astronomers group, outdoor lightning improvement, radio astronomy, solar and space exploration, all separate groups, separate meetings, separate sections, so all active to some degree, and at this point in time we're still all meeting via Zoom format, and but I think very, very soon we'll be able to get back to the club room out at Burwood, which, like I say, we haven't been to for over 18 months. I think I've forgotten how to get there. So, any more information about the Astronomical Society of Victoria? It's been around since 1922. It's coming up to its 100th anniversary. The writing to, you can write to the Secretary of the Astronomical Society of Victoria, GPO Box 1059, Melbourne 3001. So, or you can go to the ASV website at www.asv.org.au and all will be revealed. Oh, stop saying that, Clint. Alright, time is 10:13. We're broadcasting on 80 metres and 160 metres, and also via the YouTube stream, and what's the other thing I'm broadcasting by? Oh yes, the BATC website. The RTV repeater is currently off air for some reason. It is tripped. Circuit breaker has tripped. But the repeater is in fact receiving me. I am actually transmitting on 23 centimeters DVB-T2 S2 HD, and the repeater is rebroadcasting me out on the BATC stream. So we are heading out to the northern hemisphere that way. G'day Don. Don's sent an email, VK3HDX. Welcome to tonight, Don. Like I say, there's an email address you can send your reports to, VK3EKH@gmail.com. I have to think about that. Always have to think about that. There's a wonderful film on our Channel 7 network at the moment. If I wasn't here, I'd be down there watching Interstellar. It's one of my favourite science fiction movies, Matthew Mahogany and a few others there. And because it's full of commercials at the moment, the film will go on till all hours of the evening. But Interstellar is, I recommend it if you haven't seen it. Good film. I love the soundtrack, music to it, the overall feel and the storyline. Anyway, that's another story. Okay, I'll just go through a couple of little articles first before we go into Astrophys, courtesy of Brendan O'Brien's astrophys.com website. G'day Brendan, if you're listening and watching. Cheers, mate. Come on, someone send me, oh, and the chat window. Yes, chat window. I forgot to mention the chat window. I did mention it. G'day to people who are on the chat window. Richard, VK3, Victor Radio Sierra. He's a local lad. I know Tony's out there too, VK3, Victor Alpha Tango. He's a real local lad. And then there's DCB. No, I don't know if that's somebody that's called in. That's something else, I think. G'day Martin, VK7JAH. He's listening in. Bit cloudy down there in Tasmania. Yeah, I think there's a nice cold front over both Victoria and Tasmania at the moment, causing us all a little bit of a cool change to come through. We had up to 27 degrees today here in Melbourne, so that's not too bad for a nice day, nice Friday. Who else is there? Graham, VK3GRK. G'day Graham, and I think that's about it there on the chat window as we speak. Alright, this first little article I shall read. I don't think it goes for very long, that's why I chose it. Astronomers provide a field guide to exoplanets known as hot Jupiters. Published 22nd of October, pretty current. Hot Jupiters, giant gas planets that race around their host stars in extremely tight orbits, have become a little bit less mysterious thanks to a new study combining theoretical modelling with observations by the Hubble Space Telescope. While previous studies mostly focused on individual worlds classified as hot Jupiters due to their superficial similarity to the gas giant in our own solar system, the new study is the first to look at a broader population of the strange worlds. Published in Nature Astronomy, the study, led by a University of Arizona researcher, provides astronomers with an unprecedented field guide to hot Jupiters and offers insight into planet formation in general. Although astronomers think that only about 1 in 10 stars host an exoplanet in the hot Jupiter class, the peculiar planets make up a sizable portion of exoplanets discovered to date, due to the fact that they are bigger and brighter than other types of exoplanets, such as rocky, more Earth-like planets or smaller, cooler gas planets, ranging in size from about 1/3 the size of Jupiter to 10 Jupiter masses, and that's a pretty big planet. 10 Jupiter masses. All hot Jupiters orbit their host stars at an extremely close range, usually much closer than Mercury. The innermost planet in our solar system is to the Sun. A year on a typical hot Jupiter lasts hours, or at most a few days. For comparison, Mercury takes almost 3 months to complete a trip around the Sun. Because of their orbits, or because of their close orbits, most, if not all, hot Jupiters are thought to be locked in a high-speed embrace with their host stars, with one side extremely exposed to the star's radiation and the other shrouded in perpetual darkness. The surface of a typical hot Jupiter can get as hot as almost 5,000 degrees Fahrenheit, with cooler specimens reaching 1,400 degrees, hot enough to melt aluminium. The research, which was led by Megan Mansfield of NASA Sagan Fellow at the University of Arizona's Stewart Observatory, used observations made with the Hubble Space Telescope that allowed this team to directly measure mission spectra from hot Jupiters, despite the fact that the Hubble can't image any of these planets directly. These systems, these stars, and their hot Jupiters are too far away to resolve the individual star and its planets, or planet, Mansfield said. All we can see is a point, the combined light source of the two. Mansfield and her team used a method known as secondary eclipsing to tease out information from the observations that allowed them to peer deep into the planet's atmospheres and gain insights into their structure and chemical makeup. The technique involves repeated observations of the same system, catching the planet at various places in its orbit, including when it dips behind the star. We basically measure the combined light coming from the star and its planet and compare that measurements with what we see when the planet is hidden behind the star. Mansfield said, "This allows us to subtract the star's contribution and isolate the light emitted by the planet, even though we can't see it directly." The eclipse data provided the researchers with insight into the thermal structure of the atmospheres of hot Jupiters and allowed them to construct individual profiles of temperature and pressures of each one. The team then analysed near-infrared light, which is a band of wavelengths just beyond the range humans can see, coming from each hot Jupiter system for a so-called absorption features. Let me just read that paragraph again. The team then analysed near-infrared light, which is a band of wavelengths just beyond the range humans can see, coming from each hot Jupiter system for so-called absorption features. I've got that right. Because each molecule or atom has its own specific absorption profile, like a fingerprint, looking at different wavelengths allows researchers to obtain information about the chemical makeup of hot Jupiters. For example, if water is present in the planet's atmosphere, it will absorb light at 1.4 microns, which falls into the range of wavelengths that the Hubble can see very well. The team went a step further by quantifying the observational data and comparing it to models of the physical processes believed to be at work in the atmospheres of hot Jupiters. The two sets matched very well, confirming that many predictions about the planet's nature based on theoretical work appear to be correct, according to Mansfield, who said, "The findings are exciting because they were anything but guaranteed." The results suggest that all hot Jupiters, not just the 19 included in the study, are likely to contain similar sets of molecules like water, carbon monoxide, along with smaller amounts of other molecules. The differences among individual planets should mostly amount to varying relative amounts of these molecules. The findings also revealed that the observed water absorption features varied slightly from one hot Jupiter to the next. Taken together, our results tell us that there is a good chance we have the big picture items figured out, that the happening in the chemistry of these planets, Mansfield said. At the same time, each planet has its own chemical makeup and also influences what we see in our observations. According to the authors, the planets can be used to guide expectations of what astronomers might be able to see when looking at a hot Jupiter that hasn't been studied before. The launch of NASA's new news flagship telescope, the James Webb Space Telescope, slated for December 18, has exoplanet hunters excited because Webb can see in a much broader range of infrared light and will allow a much more detailed look at exoplanets, including hot Jupiters. There is a lot that we still don't know about how planets form in general, and one of the ways we try to understand how that could happen is by looking at the atmospheres of these hot Jupiters and figuring out how they got to be where they are, Mansfield said. With the Hubble data, we can look at trends by studying the water absorption, but when we are talking about the composition of the atmosphere as a whole, there are many other important molecules we want to look at, such as carbon monoxide and carbon dioxide. The James Webb Space Telescope will give us a chance to actually observe those as well. That was an article found on spaceref.com. Thank you, spaceref.com. It's titled "Astronomers Provide a Field Guide to Exoplanets Known as Hot Jupiters." You're tuned to ASV Radio, VK3 Echo Kilo Hotel. VK3 EKH at 10:25. I'll read out this next one.
Clint, your call sign's missing.
Okay. Where is that gone? There it is. Alright. Thank you. Okay, another report that's come out here on October 22, and this is also spaceref.com, but a slightly quicker article. China's Chang'e 5 lunar samples reveal new information about the moon. As we all know, China has a probe on the other side of the moon, not the dark side of the moon, just let's say the other side of the moon. The moon's largest sea may have been even stormier than its name implies, according to the first new lunar samples since the then Soviet Union lunar mission in 1976. Excuse me. In December 2020, China's Chang'e 5 collected roughly 3.8 pounds of soil and rock from the dark and relatively flat region dubbed Oceanus Procellarum, or Ocean of Storms. That's much better. Covering more than 10% of the lunar surface. An analysis of its sampled composition presented a new kind of volcanic rock that could reveal more complexity about the moon's volcanic activity. The lunar sample's characteristics were published on October 14, 2021 in National Science Review. The first comprehensive lunar assessment was based on satellite pictures in the early 1960s, and it divided the moon into two regions, namely smooth Maria, the flat, smooth Balsatic, the seas, and created highlands. Both studied with craters of various sizes, said the first author, a researcher at the National Astronomical Observatories of the Chinese Academy of Sciences. Samples are key to promoting our scientific research from our remote observations to laboratory instruments. Previous studies of the lunar surface indicated that the Maria might be filled with a balsatic rock formed from the rapid cooling of lava, while the craters were produced by impacts. Returned lunar samples from the 6 Apollo and 3 lunar missions in the last century have significantly enhanced our understanding of the moon's history and evolution, L1 said. However, the sampling focused on areas that do not represent the most widespread lunar surface features. These limited sampling sites have restricted new understandings of the moon. Researchers took 316,800 images of the CE5 samples and identified nearly 3 million particles, ranging in size from less than 10 microns, a dust or pollen particle, to 500 microns, about a quarter the thickness of a credit card. Most particles in the lunar soil was about 50 microns, the width of a human hair. Chemically, the particles are mostly free of evidence of impact debris, indicating that they are of lunar origin. They are mainly characteristic of balsate, but different from magnesium and iron-rich balsate found on Earth. Lunar balsate is low in magnesium, but high in iron oxide, according to the results. This could represent a new class of balsate, L1 noted. While this means that the Earth's criteria cannot be used to assess the lunar version, it could be a differential lunar balsate which may lead to a better understanding of the lunar volcanic activity. This compositional information suggests that the CE5 samples might represent a new lunar basalt different from previous Apollo and lunar missions. L1 also added that the presence of the lunar originated basalt combined with observations of the sample sites indicated the basalt appeared after specifically aged impacts, could reveal evidence of recent volcanic activity, and may even require new theories of volcanic activity to accommodate the varying compositions and ages of the samples. This study focused on the preliminary examination of CE5's lunar samples to provide basic information for subsequent scientific research. These samples will open an epoch-making window for studying lunar science. We've already found that the moon is so vast and more heterogeneous than we thought, so more missions to collect samples should be scheduled. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, broadcasting on 80 and 160 meters, video streaming YouTube, and also via the BATC streamer feed. Okay, it's 10:31 at this stage. I think I shall go into the Astrophys podcast, and let's see if we can just bring that up. I'll bring up the slide of Dr. Elizabeth Tasker, and bring up the audio file, and let's hope this all goes as planned. You're tuned to ASV Radio VK3EKH, and we're about to broadcast episode 10, Dr. Elizabeth Tasker, who debunks the habitability claims for Proxima Centauri b. I hope the audio comes across fairly clearly.
How are you, Elizabeth?
Good, thanks.
Very good. It's my pleasure today to speak with Dr. Elizabeth Tasker, and welcome to the show, Elizabeth.
Thank you very much.
Tell us about your background, Elizabeth, and how you initially became interested in science and then became involved in astrophysics.
Well, for most of my childhood and school years, I really wanted to be a vet. I'd read all the James Herriot books about the British vet who travels around Yorkshire caring for farm animals and